All right, let's take a look at our Unit 8 review. For question number 1, we're given data sets for A and B, and in part A, we're finding the union. So we're going to unite everything in A with everything in B and make sure we include all of it. So I'm going to want to put in a 1, a 2, a 3, 4, 5, 7, and 9. I went ahead and put it in order right away. Now for the intersection, that's just what overlaps between A and B. So I notice they both have a 1. I didn't mean to highlight the 3 there. There's only a 2 here, there's only a 3 there. They both have a, nope, not 4, they both have a 5. And I believe that's it. So our intersection is just 1 and 5. So if we're looking at Venn diagrams, the union, just as a review, is all of A or B or both, where the intersection is just that middle part where they overlap. All right, moving on to question number 2. If 40 students take a math class, 30 students take a science class, and 20 students take both math and science, how many students take math or science? I'm going to go over 2 ways on how you can do this. So the first way, if I want the number that take math or science, I can add the number of math and the number of science, but then I have to subtract the number of both math and science because I might have counted those students twice. So for math we had 40, for science we had 30, but it then told us that 20 students took both. So those 20 students are in both groups, which means I double counted them, which is why I subtract 20. So I have 40 plus 30 is 70, minus 20 is equal to 50. Now another way we had done this was using a Venn diagram. So if we do it that way, let me draw a picture. We'll let the first circle represent math, the second circle represent science. And let's start in the middle. If 20 students take both, that would go here. 30 take science. That means that, I'm going to highlight with green, this entire circle has to add to 30. So this number would be 10 because 20 plus 10 adds to a total of 30. All right, when I know that 40 students are in a math class, this entire circle for math should add to 40. So 20 plus 20 is 40. To get the answer now, I'm just adding all 3 of these numbers together. 20 plus 20 is 40, plus 10 is 50. And notice I get the same answer either way I do it. So that's number 2. All right, moving on to number 3. It says, use the Venn diagram to answer the following questions about a group of 35 students. So we have 5 questions and they all are saying how many. So we're getting numbers, not where it's probabilities and we have to divide by 35 and make it fractions because it just says how many. So how many students play soccer and volleyball? So if I look over here, and I'll go ahead and highlight and then I'll erase the highlighting before I do the next one. So here's volleyball, here's soccer. Where do those 2 overlap? This entire region here. So I would add 2 and 4 together, and my answer is 6. Okay, I'm going to erase that highlighting now to show work on the next one. How many students play only basketball? Well, here's basketball, but these 3 also play volleyball. These 7 also play soccer. These 4 play everything. So only basketball is where I just have this 6. All right, part C. How many students play soccer or basketball? So here's soccer, here's basketball, and it says or, which, just like number 2 above, I could add the total of all the soccer players and then all the basketball players and then subtract those 11 that I counted twice. Or I could simply add these 6 numbers together. So I'm going to go ahead and do it that way. So for soccer or basketball, it could be soccer only. It could be basically any of the numbers in the soccer or basketball. So 8 plus 2 plus 4 plus 7 plus 3 plus 6. So it could be only soccer, which is all this, only basketball, all this, or both, which is the middle part too. So let's see, we get 10 plus 11 is 21 plus 9. I believe that adds to 30. All right, part D is asking for how many students do not play soccer? So how many do not play soccer? Well, here's all the ones that do play soccer. So do not would be everything else left over. We're also using the complement here. So except we're not finding a probability, but we want everything else outside of soccer. So if I ignore that soccer circle, I have 5 plus 3 plus 6. So that adds to 14. All right, how many students play soccer and basketball but not volleyball? So starting over with my work here, soccer and basketball. Here's soccer and basketball. So the overlap is everything I'm highlighting here where the 4 and 7 are, but not volleyball. Well, volleyball is where the 4 was. So really I just want that 7. All right. Let's go ahead and move on to number 4. In number 4, it says, if you have 3 pairs of shoes, 6 pairs of pants, 13 shirts, and 5 hats, how many different outfits can you make? So if I have 3 ways to pick out a pair of shoes, 6 ways to pick out a pair of pants, 13 ways to pick out shirts, 5 ways to pick out hats, the total number of outfits is multiplying all these options together, or all these number of options. And this is what our fundamental counting principle is. So on a problem like this, I might get out my calculator. So let me go ahead and multiply 3 times 6, which is 18, times 13 times 5, and that is 1,170. All right, for number 5, it says that a group of 14 students are on the basketball team. How many ways can they all be introduced before a game? So think of how many students there are that could go first. There's 14 options. But now one student is first, so how many students are left for how many we can choose from in the second spot? There's 13 remaining. Now for the third spot, there's 12 remaining. And we're doing this with all 14 players. So we can multiply by 11, 10, all the way until we get to 1. Remember, this is the same as 14 factorial. And there is a button in your calculator for that. You could press the number 14 and then go to math. All the way to the right is probability, and it's option 4. It looks like an exclamation mark, but it's factorial in math. So when I do that, I'm getting 8.7178, but notice it has E10 at the end, which is like taking 10 to the 10th power. Using scientific notation here. So it's a really big number. It's like moving this decimal 10 places to the right. Another way of getting that is to do 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 if you're having trouble finding the factorial button. Part B is saying how many ways can you select a captain and a co-captain? Up here, I was using all 14 spots, but now I'm only using 2 spots. So there's 14 players to pick from for the first spot, and there's 13 players to pick from for the second spot. So in my calculator, if I do 14 times 13, I get 182. All right, number 6, it's probably very similar to problems we've already done when we did this last week. How many different license plates can be created using 3 letters and 4 numbers? First, we're allowing repeats. So if I'm doing 3 letters, there's 26 possible letters for the first spot. We are allowing repeats, so all 26 letters can be used again for the second spot, and then all 26 can be used for the third spot. And then I have 4 numbers, and if I count 0 through 9, there's 10 options there. So 10, and then another 10 for the next number because I can repeat, another 10, and another 10. So if I just do 26 times 26 times 26, I get 17576, and then I'm just going to put 4 zeros at the end of that. Then I could put a comma here and a comma here. So I get 175,760,000 possibilities. What if I can't repeat letters and digits? Well, then for the 3 letters, there's 26 ways to pick the first letter. But now that one letter is chosen, there's only 25 left for the next letter and 24 left for the letter after that. Same idea with the numbers. There's 10 possibilities for that first number, but now that one is chosen, there's only 9 remaining, then 8 remaining, and then 7 remaining. So for this part, I'm just going to put all of it in the calculator and multiply these 7 numbers together. And if I typed all that in right, I'm getting 7862400. So 78,624,000. All right, if we move on to page 2, we have a two-way table problem. So it says, given the two-way classification of 500 individuals, one person will be randomly selected to answer all the questions. Let's start by filling in the totals. So if I add up the rows, 95 plus 55 for this first row is 150 total heavy smokers. 100 plus 250 is 350 light or non-smokers. If I add up all the yes for wrinkles, I get 195, and all the no's for wrinkles is 305. And whether I add the row totals or column totals, either way, those add to 500. All right, part A, what is the probability? Notice we're finding probability now in every single part, meaning all of our answers have to be between what? It should be 0 and 1. I wanted to give you a minute to think about that first. So all probabilities have to be at least 0 and no more than 1. What is the probability that a selected individual is a heavy smoker? So I look at number of heavy smokers, 150, divided by the total, 500. And I'm just going to reduce here. So you can use your calculator, and then remember you could press the math button to change it back to a fraction. You could also just cancel the zeros, and then you could divide the top by 5 and divide the bottom by 5, so we get 3/10. What is the probability that a selected individual has prominent wrinkles? So for wrinkles, yes, we had 195 out of 500. And if I use my calculator this time, change it back to a fraction, I'm getting 39 over 100. So you just divide the top and bottom by 5 again. What is the probability that a selected individual is a heavy smoker and has prominent wrinkles? So I have an and problem. So I'm looking up in the table for heavy smoker and prominent wrinkles. And basically, where's the overlap? Think of a Venn diagram. For and, I look at where it overlaps. Well, in the table, heavy smoker and wrinkles overlaps here at those 95 out of the total 500. And once again, I can divide the top by 5 and the bottom by 5, and I get 19 over 100. What is the probability that a selected individual is a heavy smoker or has prominent wrinkles? Or is the same as the union, which is heavy smoker only, prominent wrinkles only, or both. So we're finding all of that. So I already have it highlighted up above, actually. Heavy smoker or prominent wrinkles or both. Anytime we're finding or, it includes the both. So prominent wrinkles are these two numbers. Heavy smokers are these two numbers. One option is to add these three numbers together. 100 plus 95 plus 55. And the total here is 250. But remember, it's a probability. So out of 500, and that becomes 1/2. Now the other option here is to use our addition rule. So with the addition rule, I was going to write or, but let me just kind of draw a little line here to divide it. If I want heavy smoker or prominent wrinkles, I can add up all the heavy smokers, all the prominent wrinkles, and subtract both. And then heavy smoker had a total of 150. And I'll take care of the probability part in a minute, or I could do it now over 500. Prominent wrinkles had a total of 195. Now, if I use these numbers, which were the totals, then I counted those heavy smokers that have wrinkles, those 95 people twice, so that's what I'm subtracting. Notice here I didn't have to subtract that part because I didn't use these totals. I used these numbers that were left over. Okay, so this is why it's another way you can do it. So when you add all this together, you get 250 out of 500, which also gives you 1/2. So that's 2 ways of how you could do part D. All right, the last 2 parts are a little bit different because in every problem so far we've divided by 500. 500 is our table total. This last part, let me erase my work up here. This last part is saying in E, what is the probability that a selected individual who is a heavy smoker has prominent wrinkles? So when it says who is a heavy smoker, we are only looking at this row, and there's 150 possibilities. And then what is the probability they have wrinkles? Well, 95 of those 150 had wrinkles. So if I put this in my calculator, get a decimal, 0.63 repeating, convert it back to fraction, this reduces to 19/30, which I could have also gotten by dividing the top and bottom by 5. Part F is similar to this. What is the probability that a selected individual who does not have prominent wrinkles is a light or non-smoker? So what's the given part? Who does not have prominent wrinkles? Prominent wrinkles, no. I'm only looking at this column now. Those 305 people is all I'm considering. That's my denominator. Now what's the probability of these people that we have a light or non-smoker? That's 250 out of 305. So when I reduce this, I get 50 over 61. So notice in the first 4 parts, my denominator was 500, the table total. But then in E and F, based on what was given, I had a condition that was given. I narrowed the table down to just that row or just that column, and then found the probability from there. All right, that brings us to our last problem for this review. In a glass jar, there are 8 yellow marbles, 4 red marbles, and 3 pink marbles. What is the probability of selecting a yellow or a red? So for yellow or red, I can do the probability of yellow plus the probability of red minus the probability of both. So we're talking about probabilities here. So I'm going to use that P with parentheses to show that notation. Well, the probability of yellow is 8 out of, what's our total here? We have 8 plus 4, which is 12, plus 3, which is 15. So I have 8/15ths plus the probability of red. There are 4 red out of 15. Minus, what's the probability of marble? Is red and yellow? 0. We have no marbles that are both colors. They're all one or the other. So these events are all mutually exclusive or disjoint. If I drew a Venn diagram here for these marbles, here's the red, here's the yellow, here's the pink. There's no overlap. So I get 12/15ths. And if I divide the top and bottom both by 3, this reduces to 4/5. All right, if I have, what is the probability of not selecting a red? This is a complement problem. I could do 1 minus the probability that I do select red. So the probability of red is 4/15ths. So 1 minus 4/15ths is 11/15ths. Because I changed the 1 to 15/15, and then I have a common denominator to subtract. All right, last 2 problems. The important part here is whether we have replacement or not. So in part C, it's with replacement. Part D is the same question, but without replacement. So in part C, what is the probability of selecting a yellow, then a red? So to first get a yellow marble, there are 8 out of 15. Now, if I know a yellow marble was picked and is no longer in this glass jar, there's only 14 marbles left to pick from. And what's the probability I now get a red? Well, there's still 4 reds. So I multiply 8/15ths by 4/14ths. So in my calculator, I know 8 times 4 is 32. I'm going to do 15 times 14, which is 210. And then let's see, this definitely can reduce because both numbers are even. Using the math fraction option, I get 16 over 105. Both of those can divide by 2. Last question, what is the probability of selecting a yellow marble and then a red without replacement? That is what I just did. So I made a mistake because I was not paying attention to the directions. Good thing I'm using the iPad where I can just move everything below, and now we can go back and redo part C. I'll explain D in a minute. If I'm replacing, after I do the probability of yellow 8/15, I'm putting that yellow marble back now. When I put that yellow marble back, I have all 15 marbles to pick from again. So now the probability of red is 4 out of 15. So there's 4 red out of the 15. So this is now 32 over 225. Does that reduce? Let's check in the calculator. Nope. So there's my answer. Okay, now D is what I had originally done on C by mistake. So part D is now without replacement, or once that yellow marble's picked, it is gone. So there's only 14 left to choose from, and then you get 4 out of 14 for the red. All right, so hopefully this helps. If you had any questions on any of these problems, hopefully watching this video helps you understand it a little better. And if you still have any questions, feel free to ask your teacher. All right, have a good rest of the day.